Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a paired samples t-test. In this demonstration, I will use a data file called fearofstats.sav. It contains data from a fictitious study to test the effectiveness of an intervention program designed to reduce fear of statistics. Each student was given a fear of statistics test before the intervention program and the same fear of statistics test after the intervention program. Let's begin by examining if there is a significant difference in the fear of statistics mean scores before and after the intervention program. So the first thing that we do is we go to Analyze, we go to Compare Means, then we go to Paired Samples t-test. We see that our variables are on the left and we have a paired variables box on the right. So we take the two variables that we're interested in comparing and move them over to the paired variables box. So the first variable is FOST1, which is fear of statistics time 1, which is the pretest, and FOST2, which is fear of statistics time 2, which is the post-test. Okay, we go to Options. We make sure that this is set to 95%. We also want to make sure that under missing values, exclude cases analysis by analysis is selected. We click Continue and then we click OK. In the output viewer, we first see the paired sample statistics table. SPSS gives you the mean, the number of cases in each group or the sample size, the standard deviation for each group, and the standard error of the mean in each of the groups. Okay. SPSS also gives us the Pearson correlation between the two conditions. When repeated measures are used, it is possible that the experimental conditions will correlate because the data in each condition come from the same people, and so there could be some constancy in their responses. So we see here in these results that it's a very strong correlation at 0.862, and this correlation is significant. And we say it's a very strong correlation because the correlation's coefficients range from -1 all the way up to +1, where the absolute value of 1 represents a perfect correlation. So this is a very, very strong positive correlation. The third table that we want to look at is the paired samples test. In this table, we have the mean differences between scores, which is simply this minus this. We have the standard deviation of the differences between the means and the standard error of the differences between the participant scores in each of the conditions. We also have the confidence interval, the lower and upper level confidence interval, and the t value, the degrees of freedom, and the two-tailed significance level. To find out if there is a significant difference between the two test scores, we look at the column labeled significant two-tailed. If the value in the significant two-tailed column is less than 0.05, then there is a significant difference in the mean scores of the two tests. So to interpret the data, we go back up to the paired sample statistics box and we look at the mean scores for each of the two test periods. We see that the fear scores for the pretest on average were 40.17. we see that the mean scores after the intervention were 37.50. So there was a significant decrease in fear of statistics scores after the intervention. Okay, so basically the results indicate that the intervention program appears to reduce fear of statistics. Now remember, you can never say that the intervention caused the reduction in fear in statistics because there are so many other factors that could explain that. Okay, so now you know how to run a paired samples t-test. Okay, to begin writing your results in APA format, you first indicate the particular analysis that you conducted and the specific test that you use to perform the analysis. Okay, a dependent samples t-test was conducted to determine how effective an intervention program was at reducing fear of statistics. A fear of statistics test was administered before the intervention pre-test and after the completion of the intervention post-test. The independent variable was time 1 pre-test and time 2 the post-test. Okay, the dependent continuous variable was the fear of statistics test. The higher the scores on the fear of statistics test, the greater the fear of statistics. Okay, now after we have described the dependent and independent variables, the next thing that we do is we state the null hypothesis. The null hypothesis is that there is no significant difference between the mean fear of statistics scores in the pre-test and the post-test. Conversely, the alternative hypothesis is that there is a significant difference between the pre-test and post-test fear of statistics mean scores. Now, I've given you the statistical notation of the null and alternative hypothesis if you need it. Some professors request it, but generally it is not included in your write-up. Okay, so that's why I've put this in italics. All right, now the next paragraph we actually get into the reporting of the t-test itself. The dependent samples t-test was statistically significant. Okay, that's the t, that's the degrees of freedom, and that is the actual t-value and the p-value. This should be less than 0.001 because in SPSS the significance value was 0.000. So anytime you have a situation where it's 0.000 in SPSS, the APA manual states that you have to indicate the significance by writing p is less than 0.001. Any other time you just write the actual p-value. Okay, results indicated that the fear of statistics scores after the intervention, mean, skin should be italicized, standard deviation, were significantly lower than the scores prior to the intervention. Okay, again, and italicize. The difference in the mean fear of statistics scores between the pre and post test was 2.67 with a 95% confidence interval ranging from 1.66 to 3.68. The results of Cohen's d's computation was 0.18, indicating that the intervention program had a small effect on fear of statistics scores. Based on the results of the dependent samples t-test, we reject the null hypothesis. Okay, so now let me show you how I calculated Cohen's d for the dependent samples t-test. Okay, I've created a spreadsheet here that calculates both Cohen's d and eta squared for dependent samples t-test. Okay, and the equation for Cohen's d is the t-value divided by the square root of n, which is the sample size. Okay, so our t-value was 5.394. Our sample size was 30. So therefore the resulting Cohen's d is 0.18. So when we look at our effect size chart under Cohen's d, we see that 0.18 falls under the small effect size. Okay, so basically what this means is that sure, there was a significant difference between the two mean scores. However, the difference, the actual difference between the mean scores was small. So therefore the effect of the intervention was small. Okay?
So we go back to our report and we look at our table. And in our table, we have the mean and standard deviation for the pre-test. We have the mean and standard deviation for the post-test, the t-value, the degrees of freedom, the p-value under significance, and Cohen's d, which we just calculated in the spreadsheet.
Now you know how to perform, interpret, and report an independent samples t-test using SPSS.
If you have any questions, please submit them to help@spssvideotutor@gmail.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching and much success with SPSS.